So we've been already announced as like the panel which is talking about the crystal ball and how we imagine AI and how it will shape the future. So before getting into this awesome topic, let's have a short introduction, one by one, on like your background and what you're currently working on.
Sure. So I'm Rasmus. I'm the founder of Merantix. I think I was initially invited here for a website I built during my PhD, which is called howhot.io, where you can upload a photo and it tells you how attractive you are, how old you are, and what's your gender. We had actually more than 150 million uploads, so it was quite well perceived. But now I'm doing something more serious. I recently started Merantix here in Berlin. We're a team of 10 people and basically partly work together with large companies, but partly also have our in-house project using deep learning and machine learning to build new products. And we think actually Berlin is quite a good location for this because there's a lot of talent in Germany, and there's also a lot of data in Germany and in Europe. And what we basically do is we partner with companies and form joint ventures building new products. And right now we are involved in the medical space, in the diagnostic space, in the radiology, like doing radiology diagnostics, doing stuff with blood laboratories. We are in the financial space, working on credit scoring, cash collection, and trading. And we've been recently looking into the space of creative AI. So, if you're a corporate and interested into talking to us, please see me later, or if you're looking for a job as well. Thanks.
This sounds awesome. Like, let's. Tarek, maybe you continue next.
Okay, so my name is Tarek Besold. I'm a research fellow at the University of Bremen, namely at the Digital Media Lab. I'm originally a cognitive scientist who did his PhD on cognitive aspects of human-level artificial intelligence, so the very, very crazy, very, very edgy corner. And nowadays I'm working on, among others, creative AI, so handing over creative responsibility to intelligent systems. In cognitive systems in general, so how to, for example, extract high-level rules and knowledge from low-level data, and how to close the learning cycle. And yeah, so I guess I've been invited here because computational creativity, as of lately, has gotten into the spotlight more. There's different brands of it. There is the fully autonomous creative system, but there's also what we are trying to do, namely not going into the arts, but going into ideation, going into automated science, going into automated development. And yeah, happy to be here.
So I'm the last one. So my name is Thurau. I have a background in machine learning and artificial intelligence, working in the field now for 15 years roughly. So I started as a researcher, stayed there for 10 years, then found my way into the industry. And I'm here as the co-founder of 20 Billion Neurons, which is a relatively new startup. We have an office in Berlin, that's also our headquarters, and another office in Toronto in Canada, the birthplace of deep learning. We are a heavily research-oriented company or startup, but of course we also concentrate on products. So our idea is to bring deep learning to the industry. Currently we focus a lot on computer vision, especially in videos. So we want to solve vision. That will be the short explanation for what we are doing. And yeah.
Cool. That sounds awesome. So especially for vision, like what are the current problems that you're working on? Like more concretely, like is it similar to Oculus Rift, or like what Facebook, like in the virtual reality space, or is it like in industry halls that you are advising the workers there, or what kind of solutions?
In computer vision is a huge field, right? So it basically exists now for 20 years. And for most people, it's not obvious that seeing things like objects or other things is a task which is extremely difficult for machines to do. But for humans, it's surprisingly easy. So 5 years back, we had a huge breakthrough by inventing basically deep learning and applying it on large data. So now there opens up a huge space of different applications in that field. Some include simply detecting things in photos or in video, so basically understanding photo and video. And real applications would be, for example, medical imaging, where machines are now, or will be soon, be able of analyzing fMRI scans, CT scans a lot faster than a medic, So they were also helping bringing this technology into practice. And there are a lot more fields than that. So a lot more applications, for example, in industrial quality assurance, visual quality assurance. So when you manufacture something, you might want to recognize if a car door has a scratch. So all these tasks are now pretty close to being automated.
And like when you say like those tasks are automated now already, where do you think the future will lead us? Like in 5 to 10 years in that field, in that area, like what are the crazy things that you imagine will be possible in the future?
Yes. So, well, at the moment, the current state is not really super exciting. So we can recognize cats and dogs in photos. So that's already a breakthrough somehow. But of course, you can really use that in everyday applications. What machines still cannot do is to really understand, like a human can understand, a visual scene, understand context. For example, in this room, we are so for us, it's very easy to understand. There are people here, we understand the whole scene, the whole setting. For machines, this is still very, very complicated to do. And also machines don't have an idea of common sense. So for example, if I would pick up this glass and throw it to the floor, we would know what would happen to the glass. Machines don't have that information or that idea about how the world works. So I believe machines will be able of reasoning with common sense, getting a better understanding about the world, and this will probably take place in the next, say, 5 to 10 years, and then putting machines almost on the same level as humans when it comes to visual understanding of the world.
Cool, yeah. Especially like you mentioned understanding, and that this is where like cognitive systems come in. Like when it comes to reasoning, like this is the sort of the part of the AI which is like mainly driven by having really like 3 different components where you have a knowledge representation, like a memory, and then on the other side you have a learning, like updating mechanism for this memory, and you have a reasoning that makes sense of the knowledge and of the learning in order to come up with like, is this a cat or is this a dog? So maybe you can explain a bit more in detail, since this is your specialty. What's going on there now and what can be done in the future?
Okay, I actually love Christian's optimism. Like the 5 to 10 years estimate I consider quite brave, but hey, you're running a startup, so if not you guys, who is the pioneers, right? So the actual problem with most of what deep learning currently is doing is that using huge amounts of data and significant computational power, we are capable of recognizing things which very frequently statistically appear in our data set. The problem about, for example, doing general scene descriptions and all these things you envision is what you already called common sense reasoning, what you already mentioned in terms of world and background knowledge. So what we currently are trying to do, and I'm not talking technology readiness level 5, I'm talking at around technology readiness level 1.5, right? So what we currently try to do is to somehow figure, okay, if we now have a network which can recognize cats and dogs, how can we explicitly get from it what it actually is recognizing, and does it really recognize cats and dogs in general? So can we somehow get to the knowledge level, which we then would need to do the reasoning? And as sorry as I am to say, I currently don't yet see how this happens. So people are getting closer, and people are trying to close that gap, but it's precisely the difference between seeing a rat dangling on the tail towards the ground and being able to answer what's closer to the ground, the snout or the ears. So it's precisely this understanding, getting from the rat picture to the physical properties, to having this basic understanding of gravity, of physics, and to be able to spatially answer, on which we currently are working, and, well, we are progressing, right? So there are several players trying to do common sense reasoning. There is systems which start entering that space, but in order to get up to something which is in any serious way similar to human cognition, I would rather say add an order of magnitude to the 5 to 10 years, but at least I think we're gonna get there. So,
Thanks.
Not quite as optimistic, but still optimistic that we are getting there, which is very good.
yeah, sure.
When it comes to getting there, like AI has been around for so long, like 30 years plus, especially in neural networks. And Rasmus, you you said like you're learning, you're using deep learning, which is sort of like improvement of neural networks. Like you're adding many layers in order to be able to have deep learning. Why do you think it's possible to really make sense of this technology now and have many applications where it's used already versus the fact that it has already, like the idea, the concept has been around for so long already, but it just didn't get through. So what's your say on that?
Yeah, sure. So I mean, the technology has been around for decades, but like especially in the 80s, it was really popular, but just didn't work. And I think there are mainly 3 reasons for that. So first of all, there was just not enough training data. Like if you want to learn what a cat or a dog is and you have 10 images each, because your machine can't take more, then it's very hard for the machine to automatically understand the concept of a cat or a dog. Secondly, also computation power, which I think we already heard earlier, that right now most of the deep neural networks are processed on the GPU, so on the graphics card, and they are very good at parallelizing operations and are roughly 10 times faster than running on CPUs. And also with Moore's laws, there's just much more computation power. And I think thirdly, there were just some minor changes to the architecture, to the way these networks learned, which made it possible to really get good results. And I think, especially in the media, it's often presented as if there is, like this major breakthrough. And obviously there are some very, very important breakthroughs, but in the end it's all kind of incremental. And with more data and more computation power and a couple of changes, suddenly there are a few areas where the machine is suddenly better than a human. So whether it's image classification or what we did, age recognition. And once it basically surpasses human level of performance, people start paying attention, because suddenly, before you had an expert making the call, for example, in the radiology space, before you had a radiologist looking at your X-ray image, and he had maybe seen 10,000 images before. Now soon it's going to be a machine which has seen 100 million images and is 10% better. And that's when the media starts paying attention. But it's not really that there was like one major change.
Yeah. So where do you see the future? Like which are the industries or like the use cases where in 5 to 10 years, like especially for deep learning technology, you say like there is a great potential?
So we generally start listening if a company we're talking to talks about, but you need to be an expert to understand this. Because I think basically any industry or any industry expert who is an expert and looks at data and then makes a decision, whether it's quality assurance, whether it's in the medical space, whether it's in the financial space, is going to these areas are going to be tackled with deep learning or with machine learning in general. So I think really all the areas where you have experts, even a driver in a car is somehow an expert at driving. And so I think there's going to be many changes, and most of these areas are supervised learning. So basically, you give the machine the data, and you already know what it's going to have, the decision it has to make, whether, for example, for classification, whether it's a cat or a dog. And I think in the next couple of years, also unsupervised learning will become more important, where basically you don't know yet what you're looking for, and you let the machine itself basically try to figure out what are interesting patterns in the data. And I think that's a major area of development and research, and I think there we are still quite far from human level performance in a sense. But I think if we further advance in this area, it's going to be very interesting for many applications, because then suddenly the machine can maybe see things you as a human haven't seen before.
That's sounds very exciting for the future. And one question to all of you, since you're partly from different domains of artificial intelligence, how do you think they will grow together to really to just leverage the different approaches to artificial intelligence in a combined version? Well, what do you think will happen there?
Should I answer?
Go first.
Well, that's a difficult question. So I'm not sure. I mean, if you look at robotics, for example, which would be maybe one approach where you could fuse a lot of different approaches and technologies, I do believe we will also see in robotics breakthroughs. And actually, I also believe we saw a lot of breakthroughs in the past, unlike Rasmus. So, but the current state in robotics and in more general artificial intelligence, as is hinting to that, is still at a very early stage. So I think this will take a very long time until we see something really getting combined in a more human level intelligence. The question is also if we will reach that point at all. And also if we need that, right? So as Rasmus said, I mean, right now what we see is that you can pick out individual tasks and you can already solve them extremely well, which should be fine for most applications. So, yeah.
Okay. Anything you want to add?
I actually think it's already happening. And of course, Christian, you're right, but also like being an active researcher and spending a significant amount of my time at grabbing free food at different conference buffets, we already figured, due to a couple of highly successful examples. So there is a certain big company which recently won Jeopardy and whose system, for example, also is developing cooking recipes. If you have a look at this system, it's basically an ingeniously engineered multi-paradigm system. So they do combine the different research traditions, they interface them nicely, and we see that this has some value. And also, I think there's a sociological change. Like people like, for all I know, you and myself and all of you, we've grown up in an area and in an era where we knew that there is different lines of research, and we've been educated in all of them. So in a way, it's also just our generation bringing these things together in a different way.
Yeah, I mean, maybe to quickly add, I think also it's a lot of engineering. It's not just, there's this one magic algorithm and that solves like AI. It's more like you have, like dozens very good algorithms or like a couple of very good frameworks which are very good, whether it's like with knowledge representation or with like machine learning and so on. And in the end, you kind of combine all these things and like really engineer them well so that they solve the problem you want to solve. And the problems become more and more complex. And like now, I mean, recently there were some advances that they also not just have the learning system, but also had some kind of memory they could use in the learning system. And so this is a kind of major advance in this area. And I think people will combine more and more of these things, and each of these individual things will also improve.
Yeah, thanks for these great insights for what's up for us in the future of AI. Maybe we want to ask the audience whether there are any questions. Here is one question.
Hello. Can you hear me? Okay. Thank you very much for this very interesting panel. Actually, change our future. AI might even help to predict or anticipate the future. When predicting or anticipating the future, we right now think of some things which is happening very much in advance, maybe minutes, days, or weeks. But think of anticipating just the next 200 milliseconds. I'm with a very visionary company, and we try to predict the motion of people, especially the motion of the head, within 200 milliseconds. So we want to have a minus 200 milliseconds latency. What is that good for? Especially when using VR head-mounted displays. Just think of all the computation power that you get in the cloud. So instead of using computation power on-premise, you have computation on the cloud that you can attach to. So all rendering would be done not on-premise, but with much more computing power. And even 360-degree drone flights might be much more fluent and smooth. I would like to ask you whether you think that AI should not go on only on the long-run prediction, but also on the short run.
Yeah. I think this is also happening at the moment, so at least people are trying to do that. So there's some work where people try to predict in videos the next pixels, how they appear in the future, which is an extremely difficult task because it's extremely complex, right? The dimensionality of the space is super high. So, and I'm also not convinced that this is actually the right approach to do it on a pixel level. But obviously, people are looking into this whole problem and trying to predict also human activities, which obviously makes sense, try to predict sensors. So in general, what we see is that machine learning and AI is pretty good at making a prediction, also short term, but once the complexity is too large, it just doesn't work anymore. But there are also other approaches towards that, right? So if you think about humans, I mean, when we're making a prediction about the future, also short term, we don't necessarily think in images. Instead, often what we do, we use language for that. So instead of just thinking about how every pixel in this world might look like within the next 2 seconds, I might form a sentence in my mind that tells me what would happen. And maybe this is a better approach to it, but no one knows right now.
Yeah.
Yeah, I mean, I think it's already heavily used in short-term predictions. I mean, I think the most prominent one probably is finance, where people already do it in microseconds and pre-compute a lot. Basically, use very dedicated, specialized hardware to evaluate these neural networks very quickly. So I think it's very much already in the short-term prediction game. But yeah, I mean, generally, I think it might be even easier in the short-term prediction game because it's there's much more time between the time where you want to predict something at and the current time, so it's generally an easier task.
Yeah, maybe to finance, I want to add, like I worked 7 years ago already at one of the world-leading hedge funds, and we would also do predictions of trades like based on AI, really for milli, micro, whatever seconds. They would just automatically be traded, and most of the volume on the Paris Stock Exchange was traded by that hedge fund. So it was very exciting, and I also did my PhD in reverse engineering, like how single human actions would, like what would a trader do at the next step? Like really, what would be the immediate next step in terms of trading? Would he buy or sell certain stocks to then, from the sum of all the actions of those traders, predict what is the future of the stock market, of specific indexes, which works extremely well. This also helped to fund my first startup. And so it has been around for a while. Thanks a lot.